In this video, we'll see how to factor a trinomial when the leading term is not 1. Remember, this is my A term, 3, my B term is 4, and my C term is negative 15. I'm going to try to find the factors of A times C that have a sum of B when I factor with this method. So let's look at this first example. What are the factors of AC that have a sum of B? Well, in my example here, 3 times negative 15, that's my AC. That's negative 45. And 4 is my B coefficient. So what are the factors of negative 45 that have a sum of 4? Well, if I take 9 times negative 5, I get negative 45. And when I add those two, I get positive 4. So now I am going to rewrite this polynomial, but now I am going to expand my middle term. So my first term stays the same, 3n squared, but instead of writing plus 4n, I'm going to write plus 9n minus 5n. You can see those two terms still equal 4n. I'm just expanding this a little bit. And now we're going to use what's called factor by grouping. I'm going to take my first two terms and my last two terms, and I'm going to pull out the common factor of those terms. So what's the common factor of 3n squared and 9n? That would be 3n. Well, 3n squared divided by 3n is just n, and 9n divided by 3n, that is just 3. Now, what are the factors of negative 5n and minus 15? Is there any common factors there? Sure. I could pull out negative 5. Negative 5n divided by negative 5 is just n, and negative 15 divided by negative 5 is positive 3. You can see here we have an n plus 3 in both of those terms there. So I'm going to factor out n plus 3, and then what's remaining is my second binomial. If I was to multiply these two binomials together, I would get 3n squared plus 4n minus 15. Alright, this is the same problem. I just wanted you to see here, if I change the order of my middle two terms, so 3n squared, last example we did plus 9n minus 5n, but what if you thought about it as minus 5n plus 9n minus 15? Let's look again. Let's factor by grouping. 3n squared minus 5n. What's the common factor? It is an n. So when I divide n from both those terms, I get 3n minus 5. And then for 9n minus 15, what's the common factor there? It's a 3. And when I divide 3 out of both of those terms, I get 3n minus 5. And you can see we still have that term 3n minus 5 and n plus 3. So it does not matter which order you put those middle terms, you're going to get the same answer. Okay, at first glance this problem can seem really difficult, but if we notice, I can factor out a common factor from all three of those terms. So rather than having to multiply 18 times 12 and find the factors of that, I can just factor out a 3 and get 6y squared minus 11y plus 4. This will be much easier to solve here and factor. So my AC is 6 times 4, which is 24. I need this to add the factors of 24 to add up to negative 11. That's going to be negative 3 and negative 8. So I'm going to rewrite this 3 times 6y squared minus 3y minus 8y plus 4. And now I want to factor by grouping. I get 3. I keep writing that 3 so I don't forget it. The common factor for these first two terms is a 3y. So I get 2y minus 1, and then minus the common factor of my next two terms is going to be a 4. And that's also going to be 2y. And it's going to be minus 1. Because negative 4 times negative 1, that gives me a positive 4. And so now I can rewrite this as factors of a binomial, and then I've got a constant monomial there, 3y minus 4 times 2y minus 1. All right, here are some for you to practice on your own. This first one here, I want to find the factors of 60 that add up to 19. Well, when I think about factors of 60, I could multiply 15 and 4 together to get 60, and they add up to 19. So 10a squared plus 15a plus 4a plus 6. I could pull out a 5a from my first two terms. I get 2a plus 3. I can pull out a 2 from my next two terms, 2a plus 3. And my final answer should be 5a plus 2, 2a plus 3. Okay, I sure hope for this problem you saw that you could factor out that 2, because if you did, then this problem is much, much easier. Not that you can't do it the other way, but let's see what happens when I factor out a 2. 2 times the quantity m squared plus 9m plus 18. Oh, this is much, much easier now, because now I'm just trying to find that, since my a term is 1, I want to find the factors of 18 that add up to 9. Well, that's going to be 6, and that's going to be 3. If you did this the other way and you ended up with something like 2m plus 12 times m plus 3, remember to fully factor, you'd want to pull out that common factor of 2 in the first binomial. And this would be the fully factored form. Hope you caught that. And the last one. What are the factors of 96 that when I add them together, I get negative 20? Well, I could multiply negative 12 times negative 8 to get positive 96. And when I add those together, I get negative 20. So 3y squared minus 12y minus 8y plus 32. Let's factor by grouping. Common factor for the first two is 3y, leaving me with y minus 4. And for the next two, common factor is 8, leaving me with also y minus 4. Be careful with your signs there. And I get 3y minus 8, y minus 4 as my binomials. All right, let's try one here. You know the area of the rectangle. Tell me, what are the possible lengths and widths? I'm going to find the factors of AC, which is 14, that add up to negative 13, and that is also a negative 14, pardon me. So negative 14, positive 1. I'm going to rewrite this as 2x squared minus 14x plus x minus 7. And now I am going to factor by grouping. And in order to do that, I can take 2x out of the first term, and I get x minus 7. And then look at this second pair, x minus 7. There is no common factor except for 1. So now I could write this as 1 times x minus 7. My length and width could be 2x plus 1 and x minus 7. And then finally, I want you to find a value for b that completes this expression so that the trinomial can be factored into a product of two binomials. And then I want you to factor the trinomial. So the question is, what could be B? Well, 5 times negative 15. We know that is negative 75. Well, what are some factors of negative 75? Maybe it is 25 times negative 3. So I could put 22 in here. And then, if I wanted to factor it, I would do this. Now, this is not the only right answer. You might have a different answer there. But I'm going to factor this by grouping. Notice that should be n plus 5 there, because negative 3 times positive 5 will give me my negative 15. And my final answer would be 5n minus 3. But you might have a different answer there, and that's okay, because there's more than one possible answer for this. And that's how we factor when the leading term's coefficient is not 1.